Morning all. Welcome to those that have joined so far. We're just giving it a few more minutes as I think people are just trying to access and get into the call still. Morning all. We think we're gonna start the session. It's 5 minutes past, and I think there might be people still dialing in, but we're quite a few already. So I want to welcome you all to our ANSYS Granta Material Solutions webinar. For those that don't know me yet, I am Lara van Niekerk. I'm the Business Developer and Marketing Manager for Soft, and I'm based in Stellenbosch, and I've been responsible for the Western Cape side of the business for roughly about the last 5 years. And it's my honor to introduce you today our presenter, Anne Chaperat. Might not be pronouncing that correctly. Anne is French, but we'll refer to her as Anne. She works for ANSYS Granta since 2000 and has been very much involved with the growth of the company and helping engineers to access better material information to develop products. Anne has been the channel partner for ANSYS Granta since the acquisition that took place last year. And she's responsible for France, Italy, and the emerging markets. So welcome, Anne. Thanks for being with us today. And with this, I'll hand it over to you to continue with the presentation. We are muting everybody else except the presenters.
Thank you, Lara. Can you hear me okay?
I can hear you, yes.
Okay.
I guess the rest can as well.
Okay, I hope so. Please ask questions in the chats if they come as I present, and then at the end there'll be a Q&A session for you to speak and ask your questions. I'll turn my camera off just to make sure that the bandwidth is maximized for the presentation. Okay, and I'll start presenting. I hope you can all see my screen.
Yes, we can.
So perfect. So what I've prepared today is looking at aerospace as an example case study of how you can optimize material choices in terms of optimizing your product. I just think aerospace is a good example because they normally lead the way in innovation, and they also have very strict certification requirements, which other industries do as well. So I think it's a good example, but of course it applies to many industries. I will look at a specific case study in aerospace for replacement of a bracket, which is normally machined out of aluminium. And they considered introducing PEEK to have lightweighting, and wanted to see what the cost implication would be of that change. And then we'll see also how you could go further once you've done this first investigation. What I'll start by doing is just introducing Granta as part of the ANSYS family. So Granta was started by two professors in Cambridge University, Professor Ashby and Professor Seaborn. They both still very actively involved in the company today. And what they noticed is that when you need to develop a product, you need to consider four factors. Which shape will you make it? How will what will it look like? The function, how will it behave? How will you make it? Which manufacturing process? And which material? What will you make it out of? For the first three pillars, there are some software tools, and they're very widely used in terms of optimizing. So you use CAD for optimizing the shape and considering different alternatives. For materials, there was nothing, and that's why they started Granta. They started Granta in 1994. It was just at the beginning, these two professors with some students in the university. And I joined Granta in 2000. They had just had a big investment from ASM International, which is the American Society of Materials, to help ASM digitalize their material information. And since then, we grew with our customers and with engineers to help develop the right tools to help them make the right material decisions across the development process. Excuse me. And in January 2019, we were purchased by ANSYS. There's currently 200 people working at Granta, well, within the ANSYS family. And what we aim to do is support all the ANSYS and all simulation software. So we're like a platform to help feed all these other tools. ANSYS Granta makes two products. One, which is the one we'll spend most time on today and which I will demonstrate, is called Granta Selector. Granta Selector gathers a big library of material information and helps you make choices amongst the world of known materials. So it helps you find equivalencies, it helps you find alternatives, it helps you find replacements, it helps you find completely new material. GRANTAMI is our second product. And this product is once you've made this decision and you need to acquire information about it, it helps you capitalize everything you know and share it in a very efficient way within everybody in the company so that everybody accesses one source of the material truth. And this has very big implications in terms of cost, time saving, and also error avoiding. So today, to look at Selector, I took an example which is a few years old, but which where an engineer there was a paper showing that an aerospace company was Bombardier was looking at replacing aluminium machine brackets in its aircrafts by PEEK made brackets. And they'd worked with Victrex on this. And the idea was, what if your boss looks at this, says, well, Bombardier achieved 40% weight saving in this, and you're the material expert or the R&D expert, and he's coming to you and say, hey, I saw they're doing this. Why aren't we doing the same? And is PEEK the best material? There's also PPS that has been considered. What else could we use? What would be the implications for us? And is that the best material? So if that's you, then you need to consider which polymers would meet the requirements of my application for this bracket. What kind of weight saving could we achieve? Could we do as well as what 40% weight saving? It's a lot, and that could be very beneficial to the aircraft industry. Should I consider PEEK, or is there any alternatives? How can I find information on all this data I need to make my decision? And if I optimize, how can I make sure that the design is then optimized to meet the possibility of this new material? Is there a need to qualify that new material? And are there any existing qualified materials? So to do this, I will look at, I will use CS Selector, so Granta Selector, which gathers a big library of materials and some tools to help you filter, make decisions, and estimate different alternatives. So here is the picture of all the materials that you could find available within the Granta Selector. So just in the core data, most of what we'll look at today is material universe. Within material universe, you will find about 4,000 different materials with different mechanical, thermal, I will show you different properties, and also including economic properties, so price for all the materials, so that you can take that into account in your comparison, as well as environmental impact. So if one of the initiatives that your company is having is looking at environmental impact of your products, then you could use the software to have a first estimation. Linked to the material universe, we have a vast library called JAM, which is just curve data for simulation. And we are increasing this library as quickly as we can. To go further, so once you made a you've had a first go at comparing your materials, you can then find additional data bundles, which the two biggest are the metal and polymer ones. The metal one gathers information from different standards. ASME is a very big source of information for the oil and gas and nuclear and all the pressure vessel manufacturers. And it gathers test results with very accurate information. So it's a very valuable resource. And the metal bundle adds about 100,000 different data sheets, which is very useful as well to help you find equivalencies between different countries. So, you know, metals have different names and different standards, and it's not very easy to compare them. If you have an American colleague giving you an alloy that they have used, and you want to find what the Chinese equivalency is, for example. So this is a very useful tool to do this. On the polymer side, we also have about 100,000 different data sheets in this bundle, which are for prospector plastics. It's only suppliers data sheets. So it's a very useful way for you to qualify who could then provide the material that you have selected. And in the aerospace sector, which we are looking at today, we also have a database called MMPDS. MMPDS is a very valuable tool because it gathers test results on materials which have been certified for flying. So if you do simulation, use data from MMPDS, you can definitely pass an audit trail because this is validated as a source of data for the aerospace industry. What am I doing? I made the wrong thing. And with this data, you can, I mean, it's very useful to have data, but you also need tools to make sense of the data, because without it, it can be, well, how can you find your way around it? It's a lot of information. So in Selector, we have visualization tools, which I will show you today. We have quick text searches, which allow you to find information quickly. We have comparison tools, which allow you to compare different data sheets, one next to the other, which is very useful check. We can help you apply a selection methodology. So if you think of your design criteria, you just apply them in the software. We have a little wizard to help you take into consideration the way your part will be behaving in its use. There are ways to export directly to different FE and CAD packages. And there is a very quick way to save the searches that you did and share them with colleagues by making selection reports. So I'll show you that in a minute. So if we look at the case study, what we want to do is we want to make an aircraft bracket. So if we consider how it can be, how we can think it behaves, it can be simplified as a panel loaded in bending, on which several constraints will apply. So it needs to be stiff enough to withstand the load. It will be there will be quite high temperatures which will apply to this bracket. So normally, if you think 225, you don't really think of plastics. It needs to resist impact. It can't go up in flame, which would be a big concern about polymers. And you want to make it in one, probably injection molded as a plastic. And obviously what you want to do ultimately, you will only consider this if you can significantly reduce the mass, and you want to also, if possible, reduce the cost of making your part. That would be a double whammy. So to do this, which polymer could you use? How much weight would you save? What would be the impact on the volume? What would be the impact on resistance to vibration? Let's look at that in Selector. So if I open Selector, okay, so here, I hope you can still all see my screen. Here we are in the home of in the home page of Selector. You can see that.
I'm sorry, Donnie. I just see your PowerPoint at the moment.
Okay, let me stop sharing and share again.
That's perfect. Thank you.
Okay, thank you. Thank you for letting me know. That would be a bit embarrassing for me to keep going and nobody can hear. Okay, so as you can see, you open it on Material Universe, but you can also open any of the other databases that I showed you before. So what we're trying to replace is a metal. So I can look for the aluminium. So we're trying to replace a 7075 T6. And let's have a look. So you can see you have information on the material itself. You can see which typical uses for that material. I have heard from many customers that this is quite reassuring when they do selection to check that it's you know, it's been used in similar applications before. You have composition. Why do they keep going back to the top? Let me put it in full screen. Yeah, it'll be better. You have information on price. So here I'm in pounds because I'm in the UK. But it would change with the location of where you install it. Also, in tools, in settings, you can change the units very easily. So you can go to here. I'm in GBP by automatic, but you could change the currency, and you can also change between metric unit and UK or US. So I'll stay in metric because that's the only the only way I feel quite okay. But if you need to share information with colleagues in the US, that could be useful to supply the data directly in their most preferred unit. Or if they send you information in a different unit, you can swap so you can compare. So then we have mechanical properties, some of them evolving with temperature. We have, if we go down, so because this is an aerospace alloy, we have quite a lot of information at temperature. Flexural modulus, so quite a lot of mechanical properties because it's a, well, bearing strength. Then we have information on impact resistance. We have information on resistance to temperature. Electrical information. If it was a magnetic alloy, then you would find a few more information on magnetic properties. If you need to consider whether, if you want to look for a transparent material, then if you develop for the healthcare or for the food industry, then you may want to check that there is a grade applicable for medical medical applications, and then you would find some further information if it is a medical grade on resistance to how can you clean it properly. I can't remember the word for it. Then an estimation of risk related to legislations, so REACH and ROS. Are you likely to? Is it likely to be easy to manufacture? Some a few links to a few general main processing, and then resistance to different environments, which we'll use today. Corrosion resistance only for the metals, obviously. And then environmental impact of for CO2 and energy impact for making the materials, for processing it, for recycling it at the end of life. And then at the end, some standards with different compositions. So any this is quite useful because all these can be searched for. So any text can be searched for in the datasheet. And then at the end, you can find further information. So as I said, on JAM curve data, you will find which information we have on. So if I just look at one. Oops, what have I done? Yes. So maybe look, T6 and yield, what does it say? Then you will find here test results, which you can use for simulation. And when you find a curve, you can also always find the data behind it, which you can, everything you see, you can copy and paste. So if I go back to my T6, we also had links to, I talked to you about MMPDS. So MMPDS, so you will not only find the T6, but you will find different shapes in which it's available. So if I look at a sheet, then you will find different thicknesses. Oh, I don't know. So for our bracket, maybe this one, I don't know. And then you find result of testing against different statistical validation. So, and you find the exact data of the result of that test of that material in that shape. And all this, of course, you know, with some information at crack length. So quite a lot of data which can be useful, of course, for the aerospace sector, but also in many other industries. So you see quite a wide range of data. It's a very widely used aluminium in aerospace, so there has been more tests than on other, of course, less used materials. And every information we have is supplied. Okay, so what I can do with my T6 is the materials that I was using, so I can set it as a reference. That will make it that will give it a pin that will allow me to compare all the other different materials against that material. And in my polymers, I can look at the plastics. So here they are ranked by name. And what we could do is we can look for the materials that were used. So here they were using carbon fiber PEEK filled. And we can add it to our favorites. And we could also make it a different color so it's easier to see. amongst the others. So they were also considering a PPS. See if I can. They were PEIs. So I could do the same. I could add them to my favorites. I could make them purple. And a PPS. I can add them to my favorites. And I can make them fuchsia. Okay. So you can see that you can browse. You can also do searches. So if I didn't know what a 7075 was, I could just do 7075 and find whichever information I have in Material Universe, but also in MMPDS and all the other databases I've got. So any text search you can do quickly like this. If I want to do my selection, I need to say what will I choose from. So I know I want to select a plastic. So I can start selection from any database, and from any, for Material Universe, we've done subsections so that you can access the additional data that is available just for this subsection of materials. So what did we want? We knew that we wanted to make that it would behave as a panel embedding. So how do we put that in the software? So we can make charts, and for these charts we can either pick a property against another, or we can use our little wizard where we have different components. So depending on the application that you need to do. So we've tried to put as many as possible. And then we're thinking of what will be the limiting constraints. So here it's a strength limited design. And on the y-axis, we're going to want to minimize the mass. So we're looking at the mass on that axis. And we'll do the same on the x-axis for the panel embedding with a strength limited design. And here we'll put the cost. So the benefit of considering the behavior of your part of the material in that part is that instead of considering just the cost against the density, here we're looking at the cost per unit volume divided by the strength. So it's to the half. So it's a powerful way to consider the right combination of properties for that material. Oh, and we could do relative values so we can see everything compared to my aluminium. So here what we've done is we've done a graph where we've got in brown all the composites. We've got in blue all the thermoplastics. We've got in yellow the one we colored as one of our favorites, against with some purple and some fuchsias. And in red we've got some some TPUs, and we can see where our aluminium is. So it's there. We can label it. We could see just the very quickly, just see the ones which were already selected against our aluminium, and we can see that effectively the peak in fact has a major weight reduction, almost 40%. You could see this from 1 to 0.6. But it also has quite a large cost implication, which may not be well, you need to counter. You need to take into account the fact that the aluminium was machined. So I guess the cost would need to be. You need to consider the full cost of making the part. And there is a tool in Selector for doing that. I'll not go through it today, but you can consider part cost. Actually, this afternoon there is a webinar just on that topic. And so you've got all the, but you see that you've got your favorites, but there are others. And are any of the others better than what the ones which were selected? So in order to do that, you can then add your constraints and see which of these materials still meet the requirements. So to add the constraints, you can click on the limit stage, and you can use any of the properties that we saw before and add them as, now add them as a criteria for your choice. So here we saw aluminium has a very high Young's modulus. We said here that we wanted a minimum of 10. We can add another limit for the impact resistance. So we're looking at impact strength notched. And this is not a property that is available for metals, but it is available for plastics. And here they wanted superior to 8. So I've now got only 170 materials, and I can see each time I can see the impact on my graph. So every time I make a selection, all the materials which don't pass, they become gray. So you know that they don't meet the requirements. We also wanted to do thermal. It needed to be good in heat deflection temperature. We wanted something higher to 225. Okay. And we wanted no coming up in flames. So we look at the durability, and for polymers we have a flammability index, which if we take V0, it means it won't burn. So we can take that for the polymer. We apply that. Now we only have 50, so we can look back at that range of materials. So there's a lot less, obviously. And we can the last thing we want to do is make sure that we can make it in one nice process. So we were thinking of using injection molding. So what we'll do is we'll say, okay, I only want to pick the materials which can be injection molded. So now I've only got 35 remaining. So I can go back to my graph. I can erase the ones which are gray. I can have a little zoom in. Now I see my peak. I see my aluminium. These are the PPS. The PEIs are gone. They don't meet one of the previous requirements. I see that for no additional cost implication, I could have even more weight saving with a PEC or a peak with 40% glass fiber. Now, and there's a whole range, but you see that if you want to, if your application you want to just gain in cost, then you would more look at PET, and this might be sufficient for you, but the mass gains would be minimal. If you're doing for aerospace, maybe the weight is more of an issue. So for a car or for a, you know, for an automotive application, the balance of weight to cost would not be the same as in an aerospace application. So you could see that quite quickly we came up with a list of materials which meet a list of requirements, and where we have a good idea, it's a nice picture of what the implications of one of our objectives against the other could be. Now, we also wanted to consider the implication on the design. So, you know, okay, maybe what will be the impact on the volume? So if we wanted to do this, we could copy that stage, paste it. So we now have two similar graphs. And on this one, we're gonna change the, on the x-axis, instead of looking at the cost, we're gonna look at the volume. So now we have our aluminium, and we see that for the peak, the volume would be 1.2 larger. We do have and what are these ones? So you can start looking at other things than your first. You can start exploring. And the last thing we wanted to do is we wanted to look at vibration impact. So we could do the same thing with strength. Well, instead of strength, let's look at vibration. And here we can look at the resonance frequency against the vibration amplitude. So we'll hide these, we'll do a little zoom again. So we can see that our aluminium, anything we do will have a lower vibration amplitude, but would we want to consider a bunch of materials which are in the same resonance frequency as aluminium, or do we want to consider these and then think of what the vibration impact could be? So that's, I mean, at least very quickly, you've kind of considered quite a lot of information, and you can now go back to your manager with I'll do first, I'll do cost per unit of strength. Maybe you want to go back to your first stage and compare, add to your comparison table. I also want to add my peak. I want to add the 40% peak, but then also maybe I want to look at which are these? So I could add another one of them to my table of comparison. And this will list all the materials I've chosen, and it will allow me to very quickly see how they compare to my aluminium. So very quickly, it could help me understand whether, you know, whether I didn't think of other criteria which could have a major impact on the on my design. You know, we didn't think of anything electrical. I don't think this would be an effect, but why not? you may want to see whether there's an impact for reach. So here's there's none. That's good. And once you've done this, you can make a selection report, which will very quickly take a summary of everything that you've done, and you can save it as PDF. So you can share the information of everything you've done with your colleagues very easily, so they can see everything that you've done. If someone so there's two ways in which the software is used within companies. Either there is an expert, and most people will come to that expert with questions, and then the expert will then be able to use that selection report to send them the information back of what they've done. In other companies, it's just given widely to use for everybody. And in this case, it's quite useful for people to be able to share the studies that they've done, so they can, check out, what do you think of what I've done? I mean, we always do that internally when customers ask for a study to be made. We always check with each other, what do you think? I've done this. What did I not consider? What would you have done differently? You always learn like this. The last thing which is useful is if you save that file with the design of the part, then it makes it a lot easier if there's an issue, or if you want to reconsider your choices, to then know why that decision was made for that material and to make a change. In most companies, when people need to change a material, they have no idea why that material was chosen in the first place. So I think it's quite useful to be able to keep a trace. And finally, from what I hear back from my customers, it is also, if you get audited by some customers who want to check how you have, what is your process for around materials, and in the material side on the design, I've heard back that this is a very useful tool to pass audits very successfully. So if I go back to my presentation, we've applied all these criteria in the software. We've looked at the implication on cost and mass, which are the different materials that we could do. We've looked at the impact on the volume of making the part. We've looked at the impact on vibration. So we've kind of done quite a big study in a limited amount of time. If one of our big customers is Honeywell in aerospace, and they have done some webinars with us to show how they've been using Selector in R&D to look at alternative materials, and how this has helped them not only in saving time, but also in lightweighting and saving cost. Now, as I said, once you have, if you are in the aerospace industry or in many other industries, if someone considers an alternative materials, then you will need to make sure that it goes through the whole design process. And for that, you will need a lot more information about the material. So in many aerospace companies, they have materials engineers, and material testing takes place. So if a material expert wants to use a new material, he will then need, of course, to get some qualification test done by the testing lab. In our second tool, GRANTAMI, we will then make sure that all this information is stored inside a central repository where everyone has its own view of materials. So the material testing lab will want to have access to all the material tests, but the simulation engineer just want to know the roll-up and the material card. That's all he needs. The procurement just needs the name, the minimum information, so that they can make sure they buy the right material. You don't want to you don't want the CAD people to specify material, that it rolls up into your PLM and that the procurement person then buys that material, but then the simulation people getting just info from the CAD use a different material to validate, and that then you get a failure in service because of that just lack of similar information. So having one source of information is very valuable, and also for environmental people to check about the legislative, the regulatory approval on the materials, whether it's all you who manufacture or whether you partly manufacture and partly buy in. So you could get suppliers to feed in information on your database with an incoming portal. So the software will help you from material data capture, because the reason why I considered that is because in aerospace sector it's very critical to do material testing, and material tests are very expensive, on whether you do them internally or whether you buy them out. And so having to repeat a test because you at Rolls-Royce, they measured that they had engineers repeating tests just because they didn't know it had been done before. And a material lab will repeat a test because they don't know why the engineer is requesting it again. So given the cost of tests, it makes a lot of sense to capture all that information and make sure it's shared, that it's analyzed by the expert so that it can be rolled on into models in a consistent manner, and then available directly as a plugin from your CAE or CAD. So this ensures that you have best material information at the minimum cost. Here we go. That's the end of my presentation. I hope it was clear enough for you. And I went through quite a lot, but I hope that was good. Please, if you have any questions, I'm happy to answer or try to answer.
Thanks a lot, Anne, for giving us the presentation. I'm just thinking we might need to unmute everybody, unless we just put the chats in the, let's see here, Wade's got a question. So there's one question from Wade. Can you see that, Anne?
I can see. Is high strain rate available, such as a parameter needed for the Johnson-Cook material method, which will be used in simulation? We do have some high strain rate data. For me to answer specifically, Wade, it would be useful if you just send an email with the material you would be looking for data for. And then we can check we have it. We won't have it for all materials, but we will have it for some. So we'd need to check whether we have it for the ones you're interested in. Okay. It's difficult to get that data.
Right, let's just see. Okay, wait, say this, that's good. Then I just have some general questions. Do you have data for any other industries than aerospace?
So yes, well, obviously we try to, in the material universe, we try to cover as many properties as possible. So that would be applicable for as many industries as we can find data for. But specifically, we also have the ASME code, which is very widely used in oil and gas, in nuclear, and in manufacturing in general, because of the quality of the data included. And for medical device manufacturers, we have developed a database with ASM International, which gathers not only material data, but also the devices for which they were used in the past, which saves a lot of time when you need to do certification. So if you can show the certification body that you use a material that was already used in a similar application, then it's much more, you need a lot less testing and certification. Does that answer your question?
Yeah, I think that's enough in the sense of it's an offering to more industries than just aerospace. So it's applicable to many. And then with regards to integration, are ANSYS Granta or Granta, can it only integrate with ANSYS simulation software, or would it be applicable for people who use different tools?
So we've only recently been purchased by ANSYS. So before we had to be not only simulation, but also CAD agnostic. So we worked quite hard to integrate with as many simulation and CAD tools as possible. For our GRANTAMI solution, we also have plugins for PLM. So Windchill, PT, the main three.
Okay, and then for those, oh, here's another question from a client. Can you add custom composite material specs if you create your own laminate?
You can add your own information to the software, whether it is composites or non-composites. If you already, if you want to create your own personal library of preferred materials, you can create it and save it in the software. Also, in the Granta, I'll show you quickly. We have a tool called the synthesizer, which allows you to estimate properties of different structures. So either a simple bond composite, or you know, with or a multi-layer composite, or a sandwiched panel. It's also this tool where you can estimate the part cost, which I spoke about earlier. So you can add a process and a material cost and compare one. You know, so we could have compared our composite made bracket to a machined aluminium bracket.
Okay. Janet, is that answering your question? Okay, great. Then just another general one, which is how easy would it be to implement the software?
So for Selector, it's very simple. You can install it. It's an ANSYS floating license. So you install it and you need to just link it to a server that will make sure that only, well, if you have one license, only one person uses it at the same time. And then it's released. So that's very simple. When you saw that the software is not very complicated to use, we have videos which allow you to quickly, you know, you have quick start videos which allow you to quickly remember how you use it if you don't use it every day. And then normally we do a very quick web session where we can help people and I'm sure QFinSoft could help you with that too. For MI, it requires more configuration to your specific requirements. So normally what we would do is we would talk to you about what you would need exactly, and we would then come and help you set up the system and configure it to your requirements, so you can import all your test data, and you can analyze it as you want and plug it into the CAE and CAD and PLM tools that you use. But and just to give you an idea of timing, a Granta MI project, depending on how much time you can allocate to it as well, will take between 6 months and 2 years, I would say, to have a full implementation.
Yeah, and I guess depending on the size of the implementation required as well.
And the complexity, how many different things you want to do as well.
Okay. If there's more questions from the audience, you're welcome to ask in the chat. Just one last one from my side.
There is one from Garnet.
Sorry?
There's one from Garnet. Can you run on Mac? I'm not sure. I need to check. Sorry.
The data, including the pricing, how often are Granta updating that?
So the ANSYS does 3 releases a year, and we're in line with ANSYS. So we're on 2020 release 1, 2020 release 2 will come out in early July. And for each time we update each database that we supply, we make sure it's the latest version available. And we always update the price information as part of any release. For pricing, obviously it won't be an exact price. It will be, but it's meant to give you a good approximation of where maybe a material, how it would compare to another one. So it can give you, like we said, 20% or 30% more or less. And for that, we examine trends, we import price, and we look at form as well, availability in different forms. So we have models to estimate these pricing.
Okay, so it's in line with sort of the ANSYS releases and the ANSYS model that some of the clients are familiar with.
That's correct.
Okay, any further questions from anybody? I think, to be honest, I think you've had enough questions by now, and thanks a lot. Thanks a lot for presenting today.
Just to finish, I just wanted to say, if anybody wants to see whether it would apply in their application or environment, if it would answer their specific material questions, we'll be happy to do a specific demonstration.
Yeah. So what we will do following this session, the session is recorded. We'll share it with all everybody that's registered, and then we'll schedule follow-up sessions with each individual based on their industry.
And I'm happy to share the PowerPoint if you want.
Great, that would be good.
Okay.
Okay, well, everybody, thanks for joining and enjoy the rest of your day. Thanks a lot, Anne.
Thank you.
All right, thanks, Anne.
Bye.
Thank you.
Bye-bye.